Hey guys, this is Mr. Grice for Algebra Unit 10.3 Notes. Today we're talking about linear and nonlinear regressions, the function of best fit. Our learning target today is to be able to calculate and apply the equations of the functions of the best fit by using a graphing calculator. So you will need a graphing calculator for this lesson, or you can just kind of follow along with me. So using your previous knowledge of functions, determine the type of function represented by the points in each scatter plot. So one of those is linear, one is quadratic, and one is exponential. Which one is which? Well, I'm not going to tell you. You try it first. All right, so the first one makes the shape of a J. Okay, you can kind of see it going up like that. That, if you guys remember, is exponential. Okay, and if you want to be more specific, it's exponential growth. All right, what about B? Now in class, a lot of people are like, oh, it's a parabola, it's making a U-shaped. Okay, good. Parabola is the shape, but what type of graph is it? This is a quadratic. Okay, process of elimination, C is last, that is a linear. We've been working with linears for the, sorry about that, for the past couple weeks. Okay, so A is exponential, B is quadratic, and C is linear. So far, we just calculated the equation for line of best fit using the line reg AX plus B on the graphing calculator. That only works for a linear correlation, okay? So today we're talking about the nonlinear regression of exponential and quadratic, okay? So let's take a look. We would do the same step as our linear regression. So I'm going back to our linear regression. This guy right here, we've done everything the same. The main thing now is step 4, okay? Where here we always talked about hitting the linear regression. We're no longer going to be doing that, okay? Well, it depends on what type we're doing, okay? So for linear regression, that's the line reg. For quadratic, that's the quadratic regression, quad reg. And then the last one, the EXP reg is exponential regression. So on your calculators, when you're going to calc, you can see that the line number 4 on mine is line reg, 5 is quad reg, and then if we go down, 0 is, sorry, I sneezed and was flying through all that, but 0 for mine is the exponential regression, okay? And that's going to be the main thing that's different as we're going through this, okay? And the notes on the bottom kind of show you where everything is. The exponential for ours is at 0. What we've been doing has been 4. And then quadratic was 5. Okay? So once you have the function of best fit, you must be able to apply the following parts. So mine looks a little different than what yours is. So A, linear is y equals ax plus b. So it's just in a different order. That A is your slope, and that B is the y-intercept. Okay, and our y-intercept is always 0 and a number. So yours looks real pretty right here, where it says the vertex is the maximum the maximum highest point or the minimum lowest point of the parabola. So I'm just going to rewrite that really quick. Okay, so the vertex is the maximum, which is the highest point, or the minimum, which is the lowest point of the parabola. Okay, so if it's the max, that's what it looked like, because we would see the highest point, and if it's the minimum, we would see the lowest point. Okay, now if it's not in standard form, you're going to have to figure some of this stuff out. Okay, when you're finding the vertex, remember that x equals the opposite of b over 2 times a. Okay, and to find y, we would have to substitute the value of x into the equation. Okay, and the last one, the exponential, y equals ab to the x power. Okay, so let's just go through those equations real quick. I'm going through the linear, the top left, y equals ax plus b. Quadratic in the middle, y equals ax squared plus bx plus c. And then exponential, y equals a times b to the x power. Okay, so for this, a is our initial point. Okay, it's what we start with. And the b is our base. Okay, the base, the reason why it's called the base is because the base has its own exponent. If we're talking about numbers with exponents, the b is the big number, the base. So that's why it's called the base. All right, and within that, if b is greater than 1, it represents growth. And when we find growth rate, we're going to be using that in a little bit. If b is less than 1, it's decay. Okay, so those are two formulas we're going to be using in a little bit. All right, let's look at problem number 1. It says the number of centenarians are people who are 100 years of age or older, has been growing for many years. This table shows you the number of centenarians per 1 million people for selected years since 1950. Okay, so they're saying, well, I don't know what they're saying yet because I haven't looked at the graph yet. So use your graphing calculator to create a scatter plot of the data and make sure to sketch, make a quick sketch of the graph below. So, good. Now we're in here. We're going to be inputting some data. I've already got data from last time. I need to clear that. And I'm going to input all this data right now. Okay? So I'm going to pause the video. Okay, so there's all my information. And now what we have to do is set our window. So my x min is 0, and the max that I have is 25. So I want to go a little bit higher than that. So I'm going to go to 60. Now for some of these, we can start changing our x min and y min depending on our numbers. Our y min is 16. Okay. I can go just a little bit below that to 10. And then our y max is 262, so I'm going to go to 265. Okay. And now let's see what happens when we've got our graph. Perfect. What type of graph is that? That's exponential growth. So what I want you to do is draw a quick graph of what that looks like in A. Okay, so I'm going to just come right here. So let's see, it started like right here. and it looks something like that. Okay? So what type of that is it? It's exponential. So here's the new part. To find our equation, we're going to go to Stat, go to Calculate, and we need to go down to Exponential Reg, okay? So you guys can just hit Enter right away. Mine has to go down a little bit, and then it's going to calculate. Now, before we start writing things down, what's it tell us to round to? Yeah, the 5th decimal. Okay, so y equals, rounding that number to the 5th decimal, we would write 1, 2, 3, 4. So I'm at the 9. So 6 is my 5th decimal. I need to look at the 3. And that's 4 or less, so I'm going to let it rest. Okay, now I have to write in the B. So 5 decimals, 1, 2, 3, 4. 0 is my 5th, and what's the 7 tell me to do? Tells me to round up. So it's 1.06071. Now, what I'm going to do real quick before as we move on, I'm going to put that equation into my y equals spot right here. And this is the line of best fit. So 50896 times 1.06071 raised to the x power. And now when we graph this, this is showing me my line of best fit. So I can tell if this is moderate, if it's strong, if it's perfect, is it weak, or is there no correlation? And I can say that this has strong correlation. Okay, that's not one of the questions that this is asking you, but it's something that it's important to know. All right, so approximately how many centenarians per 1 million people will be alive in the year 2013? So I know that it's asking me for years, so I'm going to have to plug something in for X. But what's that number going to be? Okay. So remember that our graph or our table says it's years since 1950. So I want to know how many years is 2013 from 1950. So I have to subtract and we get 80. So 80 is the number that we're going to be plugging into the top. Okay. And this we can just plug straight into our calculator. So I'm going to quit that screen and I'm going to plug it in. Okay, so I'm just double checking 11.50896 times 1.06071 raised to the 80th power. You can do this on your calculator too. And when we plug that in, let's see, we get 1,284.6. But once again, we're talking about people, guys. If we're talking about people, we can't have 0.6 of a person. So we are going to round this, and we're going to round this up. So it's 1,285 centenarians per million. Okay. Now, why do you think that more people, they're going to have more centenarians as the years go on? Well, guys, with medicine and all that stuff, everyone's been living longer, so that's helping us. So that's why we're going to have more centenarians. All right, E, calculate the growth rate. Okay, so growth rate of the number of centenarians per year. I'm going to come back up here, and this is our growth rate. B minus 1 times 100. Now, how do I know that it's growth rate? Two reasons. Look at the graph that we made. The graph is going up, okay? When we put it in our calculator, it's growth rate. Second, inside, if that number, the B, is greater than 1, it's growth rate, okay? So since B is greater than 1, we're using the formula B minus 1 times 100. So we have 1.06071 minus 1, and I'm going to times that by 100. And that tells us that our growth rate is 6.071% per year. So that's how the rate of the centenarians are increasing every year. Okay? Well, guys, I'm going to stop right there for video number 1. Video number 2 will be example number 2 on the opposite side. So if you have any questions on this or anything else, please come see Ms. Carranza or myself. Otherwise, this is Mr. Grice signing off for Algebra 1, Section 10.3 Notes, Video 1. Thanks for watching.